Okay, forensic students, this is part 2 of the alcon lab about doing poison and drug analysis. We are going to be focusing on the part 2 identification of illegal drugs. So this is in your data packet. Remember, there's 3 packets. There's your data packet, there's a data analysis question packet, and then there is the instruction packet. So again, we are doing the illegal drug part. So like before, you are going to do a description. So we're going to modify this a little because I want you to describe this just as much as I want you to put down, does it fluoresce? Because description of physical appearance does matter. So we're going to add in a little bit on this. Do your observation on describing it physically for all 3 of these. And I'll pull the plate in so you can see all 3. These are simulated, so if you are watching this video thinking, oh my gosh, your teacher's using these illicit drugs, they're not the actual drug. They are simulated to act like the drug. So again, this is simulated marijuana, simulated LSD, simulated cocaine. Okay, so the first thing we're going to do is our physical description. So if we look at the simulated marijuana, it's a leafy material. I have to be careful I touch it because it pops out of the well. Not because it's something that does that. It's just, it's so dry that you touch it, it causes it to flick out of the well. This is a simulated LSD. It is a fine crystalline powder. It actually is picking up moisture from the air. And then our cocaine is a very large white crystal, kind of chunky. So one of the first things that it asks for you to do is to look at the fluorescence of it. And the fluorescence is done with a black light. Now this might be a little difficult, and I actually, where did it go? Might end up putting another scoop of the powders on a black piece of paper, because when we go to do the fluorescence with black light, your white tray is actually going to glow a little purple. So it might be hard to figure out if something fluoresces. Generally, if the powder looks bright, we say it fluoresces. If it's a dark spot where the powder is, we say it does not fluoresce. I'm going to take a little bit of each, and though my scupulas are gone because I washed them, I'm going to just try to, this is simulated LSD. I'm going to try to get that out onto the black background. So that's my simulated LSD. Because then maybe if it's on the black background, you can see. And I'm going to put the simulated cocaine off to the right of that. Oh, I have to be careful because that's just going to pour out. Transfer a little bit into the cap so I have a little more control. This likes to roll, so this may not work out too well. Oh, and it's very electrostatic. I can see it sticking to the plastic cap. Again, it's simulated, so it's not how that particular powder would work. That's a piece of powder I'm going to get rid of. I'm going to have to turn off the lights. I hope it's dark enough. When I bring the black light over for you to see, so I'm going to bring the black light over. Now this might get kind of difficult with the now if this is very dark, that means that it's not fluorescing, it's not giving off a bright light. It turns a dark purplish color. There is no color variation on your marijuana. Usually I tell you I'm not going to help you through an observation. I'm helping you through the observation on this particular thing because I have the black light, and with the ladybug it doesn't work well, and if I try to use the other camera, which I will in a second, you still don't really see it. So in actuality, your LSD should have little flecks that fluoresce. This is not as dark as the cocaine. The cocaine gets very opaque, and that's why they say, oh, you know, The cocaine does not fluoresce. I don't know if I can see this and try it here. And no, it's really not working too well. I don't have enough hands. That's really what I have to do. You can almost see it. This glows a little green under the black light, and that does not. And that's kind of what you're looking for in terms of fluorescing. That it's glowing a little green as the cocaine rolls all over the place, and the cocaine stays white. And that's fluorescence. It's giving off a light as it gets excited and relaxes back down. I will turn the lights back on and we'll do the remainder of the tests. Hold on just a sec. Okay. I'm going to leave our appearance row. So we're going to go through and do the next set. There's 3 more reagents that we have to add into it to test with. And where did they go? So I'm going to add HCl. Across. Where did my HCl go? I just set it out. Here it is. So I'm going to go across with HCl, see if there is any reaction. Ooh, cocaine is bubbling. Well, that's interesting. I will try to zoom in for you. Get a little closer. Refocus. I'll poke it with one of my toothpicks. So you do see a little bit of the vegetation seeping into the HCl color-wise. It's not a clear liquid. It's turning a little yellowish green there. And this bubbled. Ooh, and if I mix it, it keeps bubbling as more gets mixed into the liquid. I'll try to shadow that a little. This seems to be floating on the top with no reaction. Now there's 2 different types of presumptive tests. One is called the Scott reagent, so I'm going to put the Scott reagent here. And the other one is called the Van Erck reagent, which is going to go there. So if you're looking at your data table, you're going to be filling in, here's Van Erck, here's my Scott. And you're looking for reactivity again. Does anything happen? The Scott smells. You're being spared that. Okay, now, if you look, nice, stir there. I don't see any more powder. Oh, that color changing? Scott should react with this if it is cocaine, and it's very faint. Oh my gosh, you can hardly see that. There is a tiny little blue color forming around the outside of the crystals. Bet you can't really see that little tiny. That's horrible. It's supposed to turn blue. And let's do the Van Erck. This dissolved. Now, the Van Erck, I'm going to shake it again. It's a little yellowish brown kind of goopy material. Oh, that's turning color. Oh, see, now you can see it just takes a while. That Scott reagent that they give in this kit must not be very concentrated. If you can look at that, you see over time that is starting to turn blue, which is what happens in a presumptive test with cocaine. Okay, so if I were to give you an unknown white powder and you checked it with a Scott reagent and it turns blue, I probably should just leave it alone. It seems to work better if I leave it alone. Then you'd say, oh, look, that looks as if I have cocaine present. Yeah, I'll leave it alone. As it sits, you can see the reaction happen. I'm going to get rid of the glare. You can see that little bit of blue that starts happening. Now on these, this changes the color again. It seems like this is reacting with the organics that are there. It's making very muddled in color. And you get almost like a brown muck, right? And I say it that way, it's not very scientific, but you can still see the leaves there, but it turns color. This turns a very deep purple. You probably can't see the purple with the way the ladybug is. This is an extremely deep purple. See, deep purple. Kind of saw that before with a different reaction with the aspirin. And then get another one. This one is different than the starting material. It's getting a darker color. Very opaque, brown, almost ruddy, where the crystals interact with the material. So those are the what we call presumptive tests that you do. You check its reactivity. You check whether it reacts with a particular agent that turns out a particular color. Like I said, with cocaine, you're looking for that blue color on the reagent. And then on this one, you're looking, this turns really purple, and this is a ruddy brown. Okay, so that is that particular part. We are also going to do the heavy metal test. So the heavy metal test is the next data table, because this is not a very long test to do. So we're going to do the heavy metal test. So we're doing this part 3. We're going to use, again, these are all simulated. It doesn't really contain lead, but it acts as if it contains lead. It acts as if it contains mercury. We have a solution that's called unknown. And then we're going to react it with another color changing. And actually, what it does, it also causes what's called a precipitate. And the precipitate's usually a particular color. This is simulated potassium chromate because chromium is not a good heavy metal to use and throw down the sink. So we use simulated so that you're not actually putting the chromium down the sink when you clean up. When I use it in AP chemistry, the solutions get filtered or evaporated depending on what I'm using, and we lab pack it out. For this one, because we have so many people doing the testing, I use a simulated one. New York. Where did it go? Oh, here it is. Guys, usually potassium chromate, the chromium is bright yellow, so this is a simulation. That's why if you go onto chemistry lab and you're like, wait a minute, that doesn't look right for chromium, that's because this is simulated chromium. All right, so we are going to take our simulated mercury and put drops into a well. All right, so we're going to start just like the data table. Mercury, I'll put lead here and unknown, and I'll try to label it in a second. And it's a quick test. It's only one test to do. Here's my lead. Here's my unknown. Now you may say, oh, I already know what it is, but be careful because it could be a more dilute, less in it concentration, so you don't have the same opaqueness. I'm going to add my simulated chromium to it. And you're trying to match, what does it match up to? Okay, normally you would see a bright yellow precipitate. Well, you actually have that with the lead. And then the mercury gives this brown precipitate. I'm looking for my, I get some more. toothpicks. Does the precipitate stay if we stir it? Yes, it does. For those of you who are still in living environment, precipitate means something that falls out of solution. Like we have snow during the winter, and that is a form of weather precipitation. When you have something fall out of solution in chemistry, when you mix two solutions together, see this is still yellow in color, that is called a precipitate. So it falls out or falls down in the solution, it's precipitation. So based on these results, in your data table, you are to identify what poisonous metal is in your unknown.